Hey students, today's lesson is on analyzing and sketching graphs. So we'll start with a key idea, and that is that graphs can show the relationship between quantities without using specific numbers on the axes. So generally we want to be pretty specific with our graphs and show numbers, but we can get a general idea of what is happening in a function just based on a sketch, even when there's no numbers. So here we see this distance and time relationship, and we can see we have an increasing distance, like we're traveling over time, and then there's no change, meaning maybe we're stopping and taking a break, right? And then it's a decreasing distance, so now we're going back home. Maybe we walked to a friend's house, and then we stayed for a while, and then we went back. And it looks like we're going back at a faster rate than we went there. So maybe we decided we're late to get home and we're walking really fast. So we can kind of think of that story in relationship to this particular graph. Let's look at some other examples of some functions. And this shows the temperature throughout the day in two different cities. And we're going to describe the change. So here we have first this town in Maine. And we can see that the temperature is increasing over time, and then it kind of slows down, and then it starts decreasing, which is kind of typical of what we see. So let's say temp increases and then decreases. We can see that no part of this function is linear either. It's the rate of change is not constant at any time. Now we have this town in Oregon, and we can see that our temperature is decreasing at a constant rate, pretty fast rate. Then our temperature is staying the same for some period of time, and then our temperature starts increasing, but at a slower rate than when it was decreasing. So we're going to say temp decreases at a constant rate. When I say constant rate, that means it's linear for that section. Decreases at a constant rate, then stays the same. And then increases at a constant rate that is less than the first rate when it was decreasing. And decreases at a constant rate. Okay, let's go ahead and look at our next example where we will sketch some graphs. So we're going to sketch a graph that represents each situation. So first we have a stopped subway train gains speed at a constant rate. Constant rate means we're going to have a straight line. Until it reaches its maximum speed. It travels at this speed for a while, then it slows down at a constant rate until coming to a stop. Okay, so that might look something like this. It starts not moving at all, right? Then it gains speed, so we have a straight line. Then it stays at the same speed. So we have a horizontal line, and then it decreases until it stops. So it decreases until it's back down to zero. So that would be a sketch of what that situation looks like. Then we have another example. As television size increases, the price increases at an increasing rate. A lot of increases in that one. So as the size gets bigger, the price is going to get bigger. So we're going to have an upward motion like this. And as the television size increases, the price increases at an increasing rate. So the slope is going to get more and more and more as we go up. So it's going to look something like this. It's always going up, but as the TV size gets bigger, that slope gets steeper. All right, that is it. Go ahead and try a few on your own. I'll see you soon.